Now that you're familiar with the basic syntax of defining a class and constructing a new object, and then working with the attributes of an individual object, let's try practicing these concepts by writing a simple Python program to model the concept of a pizza and write a function to calculate that pizza's price. We're going to begin by setting up a sample file. And in the file, I'd like you to go ahead and add the contents to the right. You can name the file ls34_object_practice.py, and I would put this in a lessons directory if you've got one. So in my VS Code, you can see that I've got a lessons directory, and inside of that, the code that you're seeing on this slide. We're also setting up the boilerplate for the main function, and I'm going to give you a chance to go ahead and work through this. I would encourage you to pause the video here before we go and use this class and show how it works. All right, so hopefully you've read the definition of this class to notice that a pizza in our model is made up of 3 different attributes: a size, an extra cheese, and toppings of string, bool, and int type respectively, and each of those attributes is given a default value. So what we're going to do next is work together through declaring a variable and initializing it to have a pizza object assigned to it, printing the size, that's the size by default, and then trying to assign some different values to each of these attributes. So I'm going to scroll down to my main function and go ahead and say a pizza object, or a pizza is a variable whose type is pizza and will be assigned a new pizza object. We're going to construct it. So remember, the constructor is the name of a class followed by some parentheses. And in doing so, we'll have a new object that's bound to the name a pizza. So we can go ahead and print size is a pizza followed by a dot. And notice below that we see the attributes that were defined on this class. So the attribute that I'm trying to print is the size attribute, right? And if I were to run this program, we would notice that it would print out medium if all is well. So let's go ahead and try that. So I'm going to open up a terminal and clear my console and try running this. And so the way that we run that is with python-m. We're running this as a module. We stored it in our lessons folder in ls34 object practice. Right? Size is medium. Great. We can additionally try changing the size. So I'm going to go ahead and above this line say something like apizza.size is large. A pizza is referring to the object bound to the one that was constructed when we made this new pizza object. The size attribute is going to be updated to be large, right? So we're overwriting the default value. So if I were to run this program again, we see that the size is now large. And I should have only used a lowercase l there. When we go to calculate the price of this, we'll assume only lowercase letters in our size attribute. Similarly, we can change some other attributes. A pizza.toppings is say 3, a pizza.extra cheese is true. Right? You'll notice that if you're using VS Code for your code completion, when you use the dot operator and it shows you what attributes are available, if you start typing the attribute and it's the only one there, or it's the top option, and you press enter, it will automatically complete the rest of that word for you. And we can go ahead and print these attributes out as well. So I'll just do toppings. So toppings is, and we can here use the string constructor to construct a string value or string representation of a pizza.toppings. All right. So here we're establishing a pizza object and printing out some of its attribute values after changing them. So notice our size is now large and our toppings is 3. All right. As a brief discussion on what's going on behind the scenes in the heap, we're next going to take a look at a diagram of what happened when we constructed this pizza object and changed these attributes. But go ahead and be sure that you're caught up at this point, and you can pause the video here. When a pizza object is constructed on the heap, what you'll notice is that we often represent this in a table. And when you see a call to a constructor, you would set up an object on the heap just like you're seeing here. And in this example, we changed apizza.size to be the string small. So apizza will be bound to a reference to this object in main's frame, right? So we haven't looked at globals yet, and that's okay. In mains frame, a pizza will be bound to this pizza object. And so apizza.size refers to the value stored here, and that size is being updated to be small. Same concept with extra cheese and toppings. So when we go to print these values out, each of those accesses will look at, say, for example, apizza.extracheese, a pizza, the dot is following our arrow, and we're always following an arrow when we see the dot operator used in this way. And we see that, okay, we've arrived at a pizza object, and now we're looking for its extra cheese attribute, and we can see that that's true. So that's the idea of how an object is represented on the heap. Next, I'd like you to try calculating the price of a pizza by writing a function named price that has a single parameter whose type is pizza, and it's going to return a float value. The logic behind this function for the computation is the base price is going to be $7 for small, $9 for medium, and $11 for large. You can assume there's no other size. And the extra cheese will add an additional $1. Each topping will add an additional 75 cents. Once you've tried implementing this function, go ahead and call it from your main function and convince yourself that your implementation was correct. Pause the video here and continue on in writing this function. All right. If you didn't quite get there, I would encourage you to follow along to the point of defining the skeleton of this function and then trying again to see if you can get any further. So if you struggled to define the skeleton, let's start at that point. So we're defining a function named price, and it takes a single parameter. I'll name this pizza, right? I'm not naming it a_pizza, just pizza, that's fine. You can use the same word to have different meanings as long as the casing is different, right? And so the capital P pizza is the class or the type that we defined. The lowercase pizza here is going to be bound to an object of type pizza. And this function is going to return a floating point value, right? We can say compute the price of a pizza object as the docstring. And when we write a skeleton of a function, we tend to set up whatever variable that we're going to use to accumulate our result. So here I might say total price is going to be a float and initially $0, right? And return total. I might just call it total actually. That would be totally fine. All right, so here we've set up the skeleton. And again, if you didn't quite get to the point of having a correctly implemented skeleton because we hadn't ever written a parameter whose type was one that we had defined before. And again, the name of this parameter could have been anything. We could have named it a_pizza. The name of a parameter only matters within the definition of a function. But go ahead and pause the video here if you need to and continue on. So we know that the base price of a pizza is dependent on its size. So we can add a conditional here. So maybe we'll say if pizza.size is equal to, and small is the first size that's specified, we can say that the total is assigned 7.0, right? So this is our base price of $7. Elif pizza.size is medium. We can assign a total of $9. And else, because we claim that there's no other possible size, so the only other option would be large, we can say total is $11. The next attribute that we were looking for was if the pizza had extra cheese, pizza.extracheese. Notice we could say if pizza.extracheese is equal to true, but because extra cheese is a Boolean already, if extra cheese is true, this would read if true. And so we don't need to add that extra level of a quality check because it's inherent in the property extra cheese being a Boolean. So we can say total is increased by $1, right? And lastly, we can increase the price of our total by the number of toppings the pizza has multiplied by 75 cents. Right? So we didn't need to write a loop to do this. We could use some basic arithmetic to add the 75 cents per topping with some algebra. Right? So now we've got a function that computes the price of a pizza. And to fit all that on one screen, I'm going to make my text a little bit smaller here. So notice we've got a little algorithm, and it's just a very basic, or I should say a little bit of arithmetic here, that is computing the price of any pizza object we give this function. So how do we actually use this function and call it? Well, back up in the main function, let's go ahead and print the price of the pizza is going to be, we're going to call price of a pizza, right? And notice that we're going to have a typing issue here because the price function returns a floating point and we're trying to concatenate this to a string. So let's go ahead and convert that to a string as well in a nested function call. All right. So now that we've called this function, I'm going to try computing the price of a large pizza with 3 toppings and extra cheese. And I go ahead and call this, and it's $14.25, which checks out because it was $11, $12, and then another $2.25 for the 3 toppings. All right. So this is how we can use an object as a parameter to a function. I want to make a quick note that's important because it's sometimes easy to fall into an old habit of declaring a variable and trying to assign values to it initially. If we were to have declared a variable named pizza1 and given it of type pizza and not initialized it to be a new pizza object by constructing a new pizza object, and we then tried to assign to its attribute size, we would see that a pizza, or in this case, and actually there's a slight error on this slide. Let me correct this. This should have said pizza1 is not defined, right? So the way that we fix this is we would say pizza1 is a variable of type pizza, and it's initialized to a new pizza object. We're constructing a new pizza object. And then after we've done this construction step and assigned the reference returned to us to the pizza variable, then we can start working with its attributes, right? One of the things that you should know is that because modern Python and the type checking that's involved in being sure that we only use this pizza1 variable as a type pizza, because if you construct your pizza object or any object on the same line that you're declaring the variable or first using the variable that it's going to be bound to, our programming language can infer the fact that, oh, yeah, of course, pizza1's type is going to be type pizza because you're initializing it to a new pizza object at the very same time. Right? So you are encouraged, once you're comfortable with the idea that pizza1 in this example would store an object of type pizza, you're totally fine with omitting the type here and just constructing that object and assigning it to the variable directly as part of the initialization step. The bundling of these attributes, these related values, is one of the important benefits of objects. So consider this price function that we just wrote. We could have written this exact same function earlier, but without using objects and given the function 3 parameters, the size, whether or not it has extra cheese, and the number of toppings. But once we've defined the concept of a pizza, we're able to give it a bundling of those same 3 values as a single parameter. And not only is that a little bit more concise to use, but the semantics are improved, right? That first price function could have been calculating the price of a cheeseburger, not a pizza. But the second price function is definitely calculating the price of a pizza, right? Because we're giving it some value of type pizza. If our object had far more properties, and if this was a real modeling of a pizza, like you might order from Pizza Hut or Domino's, you would have far more attributes in the modeling of the idea of a pizza. And you can imagine that as your number of attributes grows, the ability to bundle them all together and pass them around your program to various functions becomes much, much more pleasant to work with than if you needed to pass around all of those attributes individually and keep track of them individually as well. So this is a quick introduction to or tutorial in using objects and defining our own class, constructing an object of that class, and then writing functions that can operate on our objects. As we move forward in the course, we'll be adding additional capabilities to our objects by defining methods and constructors on our classes. We'll take a look at that in a lecture ahead.